I would like to make a video on how to determine which is the correct kinematic formula to use. Which equation should you use when you read a word problem? How do you determine which is the correct formula? So I'm going to explain that real quick. So each of the formulas has 4 variables in it. But there are 5 kinematic variables. 5 kinematic variables are velocity or final velocity, initial velocity, acceleration, time, and distance. So there's 5 variables, but each of the equations only have 4 variables in them. So each equation is missing one of the variables. This one is missing distance. This one is missing acceleration. This one is missing velocity. And this one is missing time. When you're trying to determine which equation to pick, when you read the question you're trying to answer, 3 of the variables in the equation will be given to you. And the 4th one will be the one they're asking for. The one that's missing won't even be mentioned in the question at all. So that's the key. There's 2 ways to figure out which equation you're going to choose. Either look for what is missing from the question completely, or match up the variables, the 3 they give you, plus the 4th one that they're asking for. So let's look at an example question and try and determine which equation we want to use. Okay, here's our example question. A baseball is moving at a speed of 2.0 meters per second when it strikes the catcher's glove. The padding of the glove is compressed by 0.024 meters before the ball comes to a stop. We want to find the average acceleration of the ball while it is compressing the glove. So in kinematic equations, what we first want to do is go through and figure out what variables we have. So I'm going to go through and circle everything that is a variable in the question. A baseball is moving at a speed of 2.0 meters per second when it strikes the catcher's glove. Okay, so this is our initial velocity, or our starting velocity. So we've got V0, or VI. The padding of the glove is compressed by 0.024 meters. This is a distance. We've got distance before the ball comes to a stop. So 0 is our final velocity. So this is one of those where it's not given to you as a number, but it's expressed in the form of words, like keywords, like comes to a stop or starts from rest. These are keywords that tell you the number should be 0. We want to find the average acceleration of the ball. So this isn't given to you, but this is asked for. So we need to find an equation that has these 4 variables in it. Initial velocity, distance, velocity, and acceleration. So let's look over here. We've got, this one has time, so it's not that one. This one has time, so it's not that one. And this one has time, so it's not that one. Remember, we figured out the 4 variables that were in there. What is it missing? It's missing time. It does have final velocity, initial velocity, acceleration, and distance. So this is the equation that we need to use if we want to answer this question. Let's do another one. Okay, here's our second example. A watermelon is dropped from the top of an 80-meter tall building. We want to find the velocity of the melon after it falls for 2.5 seconds. So let's go through and pick out our variables. This is almost a trick question, and if you're not careful, you're going to fall for it. A watermelon is dropped from the top of an 80-meter tall building. We want to find the velocity of the melon after it falls for 2.5 seconds. So picture this 80-meter tall building. We're going to drop a watermelon. After 2.5 seconds, we don't know if it's hit the ground yet. So this 80 meters doesn't matter in our problem, because the distance should be the distance after 2.5 seconds. So let's leave this distance out for now. What we do know is the time. The time was 2.5 seconds. We know that it was dropped. So dropped means it started from 0. So our initial velocity is 0 meters per second. We want to find the velocity after the time. So our velocity is what we want to find. So what's our fourth variable that we know if we're not using this for distance? Well, remember, when something's dropped on Earth, it's going to have the same acceleration, and that is going to be negative 9.8 meters per second squared. We'll use that for our acceleration. So now we know we've got time, initial velocity, final velocity, and acceleration. And we're missing distance, right? So if we're missing distance, we've got all of these. This is the equation we want to use. So we can figure out how fast the melon is moving after 2.5 seconds. I hope this video was helpful. Let me know. Take care.